In this video, I'll be discussing the third problem of JEE Advanced 2025 Maths Paper 1. So like we were given a function f of x is 2 minus 2x square minus x square sin x, sin 1 by x, when x not equals to 0, and when x is equals to 0 it is 2. And like we have to check the following options. So like first option, like if we see the first option, like we are having f of x is not differentiable at x is equals to 0. So we need to check the differentiability of f of x at x is equals to 0. So that can be done by taking the left hand derivative. So if we take the LHD at 0, so that is like limit h tends to 0, f of 0 minus f of minus h by h. So that is equals to limit h tends to 0, 2 minus 2 into minus h whole square sine 1 by minus h by h. And that is equals to limit h tends to 0, 2 minus 2h square plus h square sine 1 by h. And that is nothing but limit h tends to 0, 2h square minus h square sine 1 by h. And like if we closely observe this thing, so this is nothing but 0. Because like 2h minus h into sine 1 by x, as h tends to 0, 2h tends to 0, and h into sine 1 by h, like 0 into sine, like some bounded value between minus 1 to 1. So basically this is 0 minus 0, which is 0. Now in the similar way, like if we try to observe like RHD, so we are getting limit h tends to 0, f of h minus f of 0 by h. So that is nothing but limit h tends to 0, 2 minus 2h square minus h square sine 1 by h minus 2 whole divided by h. And that is like very much similar to the previous part. So minus 2h square minus h square sine 1 by h, and that is nothing but 0. So f dash of 0 plus and is equals to f dash of 0 minus. Both the left hand derivative and right hand derivative are same. So that means like f of x is differentiable at x is equals to 0. So that means like the first option is wrong, because they are saying f of x is not differentiable at x is equals to 0. So but like we can check by first principle that it is differentiable. Now so we can clearly say first option is wrong. Now let's come to the second option. There is a positive real number delta such that f is decreasing function on the interval 0 to delta. So for that, like if we take the derivative of f of x, so f dash of x will just be minus 4x minus x square cos 1 by x into minus 1 by x square minus sine 1 by x into 2x, which is nothing but minus 4x plus cos 1 by x minus 2x sine 1 by x. Now like for some h belongs to 0 to delta, so f dash of h, if we consider f dash of h, that is cos 1 by h minus 4h plus 2h sine 1 by h. Now like we can't really comment about this particular value, because we can see like sine 1 by h and cos 1 by h, these are oscillatory functions, like oscillatory at x, they have like oscillatory nature at x is equals to 0. Now since they are having like oscillatory nature at x is equals to 0, we can't really say whether this is less than 0 or whether this is greater than 0 at that particular point, or like or in the region between 0 to delta. We can't really say like whether this function is decreasing or whether the function is increasing. So in the similar way, like if we consider option C, so we can clearly eliminate second option as well, because we can't for sure say that f dash of x is less than 0 in the range of 0 to 5. The derivative is not negative in the interval 0 to delta. So we can't really say whether that function is either decreasing or increasing for sure, because we don't know, like we don't know the value, whether it is negative or whether it is positive, we are not sure. So we're not really sure about the sign of the derivative in that range. So that's why we can definitely say that f is not necessarily be a decreasing function in this interval, so we're eliminating option B. Now, like if we consider option C, so for option C it's the same process. So again, like if I find, so for option C, suppose like for some minus h, like this time, like if I consider some minus h which belongs to minus delta comma 0, so f dash of minus h is cos of 1 by h plus 4h minus 2h sine 1 by h. Now again, like clearly, like we can't really say like anything, like whether this value is greater than 0 or less than 0. We can't really say because like we're unsure about the values of cos 1 by h and sine 1 by h near the minus, in the interval minus delta to 0, because they are of oscillatory nature. So that means like yes, I think like this option is correct because f is not an increasing function. So we can say like, I mean, it is not an increasing function because we are not, I mean, like we can clearly see it's not greater than 0 and it's not less than 0. Now if we see the last option, x is equals to 0 is a point of local minima. So that means like if we take the derivative, the same thing. So if we see the f dash of x, so that is nothing but minus 4x plus cos 1 by x minus 2x sine 1 by x. Now this f dash of 0 is like, first of all, like f dash of 0 is not 0. Like we can see it is something like cos 1 by h, like again, like that's of oscillatory nature. So we can say like, I mean, it is, I mean, like we can't for sure say that it is 0, like it can also be some non-zero value, or basically it's oscillating at near 0. Now second way to see this, so we are not sure like whether the derivative is 0 or not because of its oscillatory nature. Now the other way of seeing whether it is a local minima or local maxima, so for local minima at x is equals to a, so the function like at a minus, the function should be decreasing, so that means derivative is less than 0, and in the a plus, the right side neighborhood, the derivative should be positive. So basically if the function is decreasing and then increasing, so that's where like we'll be having the local minima. So that means like, so here like we can try to find what is f dash of 0 minus. So if we try to see like f dash of 0 minus, so f dash of 0 minus is or like f of f dash of 0 minus. So we can't really comment about this particular thing because like f dash of, if we consider f of 0 minus and f of 0 plus, so both of them are like we can say for sure, like from the function, so we can say like both of them are less than 2, and at x is equals to 0 it is 2. So this is less than 2, this is less than 2, and f of 0 it is 2. So the nature is somewhat as a, like it is less than 2, and at 0 it is 2, and again like after 0 it is again less than 2. So that means like it's not local minima for sure because the just before and just after the values are less than this 2. So that's how like we can eliminate option D as well, and we can clearly see option C is the correct answer for this. That's it for this video.